One more example problem in electrostatics. So let's put it all together with some examples from your worksheet. On your worksheet, don't try to solve these problems on the worksheet itself. You don't have enough space to do that. This is problem number 15. An electron is immersed in an E field, an electric field of 20 newtons per coulomb. What force does it feel? So at this point, to calculate the force on a charged particle, you can look at F equals ma or F equals QE. So if you know the mass of the particle and its acceleration, you could use that equation. If you know the charge in the electric field, you can use the F equals QE equation. So let's take a look at our givens. In our givens, we know that the electric field is 20 newtons per coulomb, so we had kind of a unit clue that we're looking at an electric field there. And the charge is charge of an electron, because it tells us it's an electron. Now the charge of an electron we can look up on some kind of constant sheet, or even using Google, you can look up the charge of an electron. And we're going to use it as 1.6, or negative 1.6 times 10 to the negative 19 coulombs from a constant sheet. Now I'm all set. I'm looking for the force. So for the force, got to remember when solving these problems to use F equals QE to determine the force's magnitude. The sign doesn't matter, so we're going to reason out the direction later on. So just for finding the magnitude of the force, just ignore the negative sign. So the equation is F equals QE, looking at the absolute value of the charge times the electric field. So our force is 3.2 times 10 to the negative 18 newtons. One little word of caution here on using your calculators. The format of the correct answer is 3.2 times 10 to the negative 18 newtons. Do not write it as 3.2 e negative 18 newtons. That's wrong. Your calculator is using shorthand to text you the answer, and you're supposed to take that and put it into its formal writing. That's 3.2 times 10 to the negative 18 newtons. Consider yourself warned.